CFM and square footage, part one,
Part one.
and only one.
Part two. Okay, like we said before, homes built before 1975 had minimal insulation in the attic, and they didn't have insulation in the walls. So, if you figured the square footage per CFM, 20 by 30, in this example will be 600 square
Length
feet.
by width.
That can be figured at 1 CFM per square foot, right? We'll talk about that, right?
Yeah.
Now, homes that are built after 1975 can be figured at 0.8 CFM. So our little example here is 30 by 20 is 600 square feet times 0.8, 480 CFM. We've all done this, right? We've all
Yeah.
worked these formulas out, right? Simple. Okay. Commercial buildings. We have an example of 600 square feet, right? Can be figured at 1.2 to 1.7 CFM per square feet. So, the amount of CFM is required to cool a commercial space that's 600 square feet is 720. You guys remember doing Little Joe's?
Yep.
Yeah.
Remember square footage per CFM on that?
It's like
Yeah.
1.2.
Yeah, it was like
1.3
0.2
or
something.
Yeah. And Little Joe's was commercial, right? Okay, some facts. All air conditioning is 400 CFM per ton. All air conditioning is 12,000 BTUs per ton. Most duct systems are designed for 0.08 static pressure. New homes with new high efficiency units may be designed at 0.4 to 0.5 because of the metal ductwork that they're putting in the new homes now. Air velocity at the register should be kept below 600. You guys know all that, right?
Yeah.
Okay, here's something you don't know. Are you ready?
Yeah.
Yep.
Oh, look at that.
Cubic feet. Okay, so our example, at 8 foot tall, we have cubic feet of what?
4,800 feet.
4,800, right? Okay, so we're looking at cubic feet as far as sizing equipment. Why would we need to do that?
To make sure we have the right size AC unit for the house.
Because we need a minimum of 6 air changes per hour. Look right there, a minimum of 6 air changes per hour is ideal. So 6 times 4,800 equals 288, or 28,800 cubic feet per hour. Divide that by 60, gives us 480 CFM.
Oh.
You get that?
Yeah, I do
Okay,
now.
I understand.
Uh-huh.
Sorry,
Yeah.
can you say that again, Steve?
You can read it, it's right there.
Yeah, you can read it right there.
Yeah, that was not that hard.
6 air changes means that this air in this cube has to be changed 6 times per hour. Has to be completely removed and put back 6 times per hour. So 6 times per hour, that means that 28,800 cubic feet per hour. Okay, you see that?
Yes,
That's
thank you.
cubic feet per hour, right? So we divide by 60, that gives us minutes. So 28,800 divided by 60 is 480 cubic feet per minute.
Okay, okay.
You got that? Am I losing you guys?
No.
Told you it was gonna get gnarly. Hasn't gotten gnarly yet. Okay. So we want a minimum of 6 air changes per hour. Do I need to separate you two?
What? No, I'm trying to pay attention to this.
Yeah.
You're talking nonsense, Steve.
CFM is cubic feet per. So that's
Okay, you guys remember load count? Remember load count? We did load count?
Yeah.
Everybody got
Yes,
that?
I do.
Everybody got those 3 load counts?
Yep.
You got them with you?
They're
Yeah.
probably in my backpack.
Actually, no.
He doesn't
No,
never
I
had
don't.
anything like
You know, anybody have them handy?
I can find mine.
Well, I was thinking if it was in my car when I cleaned out my car.
Is it really gonna be relevant that I find this though?
Yeah, we're gonna talk about all, we're gonna talk about all two of them.
Give me a
Remember,
second.
remember those? Example of low calc, remember the first one, low calc one? Remember low calc one? Remember?
Yeah.
Yeah,
Yeah, that's the computer thing we did.
Yeah,
it'll be somewhere here.
it was 1, 2, and 3. Who's gonna find it first?
That's not a
Who's
race.
gonna
but-
find it
I don't
first?
even know how.
Who's gonna find
I'm
it
too
first?
competitive for that. Still got all my typing stuff. FEMA, woo, FEMA.
Anybody?
Anybody?
I don't know how it
No,
goes.
I don't think.
It's the one that measurement from the glass and everything for the house.
Oh,
On the
I just
computer.
got way too much paper going on here, find it.
The,
Oh, shit, look, I got you this one.
I feel like it'll be a week where it's just like.
Kinda, I'm giving up.
want me to look for it for you? You got it, where is it? Where is it? Right here, dude. There. What's this one? Is this
that's
two?
this one, right? It's a big question.
Locale
That's a
for,
good question.
because they want.
Oh, is it this one?
You get one.
Yeah. Okay, so is this one or two? That one's one. That one's one. You got two? This one's three.
Man,
Four,
makers
you
can't
do
be
one.
choosers.
You don't wanna use my three, cause my three is probably up.
Okay, so we did low calc one, we ended up with, what size unit?
5.
I'm just gonna say oh.
5.
Okay, 2000 CFM is a 5-ton unit, right? You got that? Okay. We had 1,652 square feet. Equals 1.2 CFM per square feet. Okay, so cubic feet
Oh, come on, right there.
was 13,216 cubic feet times 6 air changes is 79,296 cubic feet per hour. Got that so far?
Okay, alright.
Okay, 5-ton, this is what a 5-ton will give you, is 2,000 CFM times 60, it'll give you 120,000 CFM per hour. Cubic feet per hour, or about 9 air changes per hour. Okay, that's the first one we did, that was low calc, right? We good with that so far? Okay. So is it 6 air changes that we talked about? Need to go back? Was that
No,
6
no,
air
6.
changes?
6.5.
Oh, 6. Yeah, we need a minimum of 6.
6.5.
About
You got
9
6?
changes per hour.
9. Wow. 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 Wow, okay. So that was low calc number 1. Let's go to low calc number 3. Low calc number 3 worked out to be what? 3 tons?
Approximately
3 tons of cooling, right? Okay, so a 3-ton air conditioning unit is gonna deliver 1,200 CFM. Divided by 1,652 square feet, that's a 0.7 CFM per square foot. So if we look at the cubic feet, so 13,216 cubic feet times 6 air changes, we're gonna get 79,296 cubic feet per hour. A 3-ton at 1,200 CFM times 60 is gonna give us 72,000 cubic feet per hour. So it's about 5.4 air changes per hour. See that? So what are you gonna do? What are you gonna do?
The numbers.
What are you gonna do? Huh?
Four times.
No. 3.5 ton. I would have to go with 3.5 ton on that. Because of the air changes. Because I'm not quite at 6, so we do a 3.5 ton, even though the low calc worked out at 3 ton. You're gonna have to get those air changes back up. So approximately, here's a 3.5, that's what it looks like. 3.5 ton gives you 1,400 CFM, and you got a 0.84 CFM per square foot. So you need 79,296, and you have 84,000 cubic feet per hour. Or about 6.3 air changes per hour. Enough. Is like that?
Yeah. Let's do it one more time.
What?
One more time?
One more time. Let's go back about 4 slides.
Oh.
Start all over.
1, 2, 3. Not just 3 slides over. Go forward one.
What don't you get? Why?
I could explain it to you. How about that?
Yeah, no, we're good, Steve.
No.
If she needs
Hey.
extra help, she needs.
Marcia's got
So we get the idea about the air changes. Now, this is one other way that we're gonna have to deal with doing load counts and sizing ductwork and loading up the building. Right? For airflow. Now, as far as I know, Title 24 has not implemented this 6 air changes per hour into their standards. They may have, but I don't know, but, we had an instructor that I was talking to in Reading, and they were saying they were building apartments that weren't meeting the air changes per hour. And they were having problems with, high humidity and not enough air movement and stagnant air, mold, stuff like that, in the new construction. So they're not looking at it. I was talking to them, I said, aren't they doing the air changes? They said, they're not considering the air changes, they're just putting units up there. So he says, I'm finding a lot of this one apartment complex where the units don't have enough airflow. Okay, so in that case, we gotta make sure that we move enough air out of that house to not have that stagnant air, that moisture problem, or that mold problem, right? So you can be really super efficient, really super efficient. You could get more efficient than the 3 ton that we put on load calc, right? You could actually build that house with 6-inch walls, put insulation in those walls, right? Or 19. Really bring it down to 2 tons, right? But you're not making the 6 air changes, so you're gonna run into problems. So there's only a point where you can get so efficient, and when you get so efficient, guess what? You start losing it. It just falls off. You can't, something else goes on, something else happens. Seeing what it's, yeah? I understand that. Okay. So you can only be so efficient, and that's it.
Wait, Steve.
Huh?
What are you not getting?
To the packet.
Explain it to,
Okay, I'll
Jessica.
explain to her later. I don't.
I think you forgot.
explain it to her and you'll get it.
Yeah. Reduce
I don't
yourself.
understand what it.
Yeah.
I told you it's gonna be
You
another.
could.
Length
I understand so much.
is-
Couldn't really explain it.
Air changes,
Air change.
air changes per hour. I'll give you a little free one. You want a little free one? I'll tell you a little free one.
Ooh,
Freon?
Free one.
free one.
Free one. How many of you guys ever been in a building where there was evaporative cooling?
Yes.
Those little water coolers, right?
Here.
Water
Okay.
cooler, huh?
That's what I have in my window, my house, water cooler.
No.
Cool.
Why do you have a filter?
Really? What?
Are
Oh,
you
yeah.
sure it's not just for window AC?
No, I don't ever use it, I don't like it, it's too muggy.
Okay, too muggy.
Yeah, like if
Too
it's too
muggy.
hot outside,
Too muggy.
too muggy.
Guess what? The problem is not the water cooler. The
Hot
problem is the size of the water cooler. So most water coolers that I see on houses are incorrectly sized.
That's true. Everyone just wants the biggest one.
Well, PG&E just wants to give out the free one, so.
No. Actually, if you're looking for, it shows you right on the side of the package when you buy a water cooler, what size you need. And people say, oh, that's a good size there. And
Depends on where you have it in the house too, it's in a small room.
No, you just open up the window in the other end of the house.
Yeah, no, you know what, when the weather's perfect, it's perfect. Good, continue,
It
Steve.
might be too small.
No, mine is too small.
So when sizing a water cooler, this is what you gotta do. You have to figure your cubic feet. So what's your cubic feet? What's cubic feet in your
What, it's this,
In
this
your-
the,
house? In your
oh,
apartment?
I think it's 1,000, but it's anywhere from I think it's about 950.
Cubic feet?
Cubic?
Oh, cubic, oh no, I think you meant just like the,
Web
So
times,
it's-
length
I-
times.
Square feet
Okay.
times.
I was looking at square footage, okay? I don't know what cubic.
Okay, well, you know what, why don't we take our little example here, and we'll go cubic feet. Remember our cubic feet for our house?
Yes.
Yeah.
13, 260 cubic feet, reads. Okay, so in this area, which is the Central Valley / area, there's a map on there and it shows you what area you're in. It requires 2 minutes per air change. So you're gonna move that air out of that house and change that air once every 2 minutes. Okay? So we're gonna figure out what our cubic feet per minute is. So how many times we gotta change that out, right? So this is, we'll do it divided by, if it's hours, then we're gonna divide it by 2, right? 2 minutes per air change, 2 minutes per air change. Some parts in the United States, 1 minute per air change, or 1.5 minutes per air change, where it's really dry, Arizona, New Mexico, stuff like that. Okay, so what's that in half? So if we divide that by 2, what?
I don't know.
13, 216 divided by 2, that's 6,608.
And 8,
Yes.
CFM.
With the,
CFM, that's the size you're gonna need. That's the biggest size that they've got for residential. 6,500, that's the biggest one they got, and then you're gonna be a little bit light anyway. And then you probably won't get that 6,500 anyway. Just like when we took the measurement here, we didn't quite get 1,600 CFM.
we got close to it.
Yeah, it was close, but we were like, at night, I know we were about 50 CFM over. So this is the proper way to size that cooler. If you do that, then you're not gonna be, it's not gonna be real muggy, it's not gonna feel like it's stuffy, or it's not like, you're gonna have enough airflow to move that air, to get that air out of there and provide a cooling effect. You don't believe me?
I do believe you, you're the teacher.
We did, and I've seen this happen, I've seen this in People's Church gym. When they were remodeling the sanctuary in People's Church, they were having church in the Fresno Christian gym. Wow. And it was the middle of the summer. Wow. So they had a couple of evaporative coolers for the gym that was on a platform outside, up above the locker rooms and stuff. But that wasn't enough to cool that building. So we put in 3 evaporator coolers, big commercial, they were called master cools at the time. They were like, I think, they're about 120 CFM each, something like that. So we put 3 of them on the roof. And we also put 3 exhaust fans on the roof. So when they kicked on those extra coolers, they had exhaust fans to pull the air out. I went in there one time, it was 105 degrees, 105, and they were having that little craft fair in there. And I'm thinking, yeah, okay, we'll see how this thing works. So I went up there and I got the cooler wasn't, one of the coolers wasn't working, or 2, it was something like that. It had to be reset, so I went up on the roof and I reset it and I got everything running. And then I came down, roof hatch. Then I went out into the floor, right? And it was nice in there. I mean, it was about 75 degrees in there. It was 105 outside, all evaporative cooling. But because we had enough air to move, that air didn't feel like it was, so the more air you move, the better off you're gonna be with water tools. Okay, so they can work really well, but the problem I've always seen is they just don't size them the right way. They're not sized correctly. Okay, we good?
Yeah.
Oh boy.
That is the end of this